Hi, this is Matt Erion. Thanks for your attention to my project today. I'm attempting to design a musical expression instrument for the locked-in syndrome client. I've been interested in news stories about how computer interfaces can aid all kinds of clients in communicating. It's through these reports that I first become aware of locked-in syndrome. Locked-in syndrome, or LIS as it's abbreviated, has received the name as the patient is conscious and aware, but unable to move or apparently communicate. This inability to communicate leads to misdiagnosis and improper treatment. LIS can onset quickly as the result of an injury, or there are progressive neurologic diseases that can cause LIS to manifest. Recovery from LIS is rare, but it has happened. Martin Pistorius is an individual who recovered. Here is his description of LIS. It's like a cold, sinister, frustrating, and frightening feeling, which seems to throttle every cell in your body. It was like you're a ghost witnessing life unfold in front of you and nobody knows you were there. These USA figures for Alzheimer's and Parkinson's are relevant as these conditions can progress to cause enough neurological damage to trigger LIS in a client. Given the difficulty with diagnosis, we don't have an exact figure of LIS patients, but it is thought to be in the tens of thousands. Some LIS patients have been treated with music therapy. Much like any client, music therapy can support many goals. Key for the LIS client is communication, belonging, and having a sense of purpose. While the prognosis for the LIS patient can be dire, neurologic music therapy interventions could possibly have benefits. My original inspiration for my instrument came from Human Instruments in the UK. They were in the news earlier this semester for developing their haptic baton, a conductor's baton that can send vibrations to a blind musician. This will enable blind classical musicians to play with full orchestras for the first time. Here, musician John Kelly describes another of their projects, the touch chord.
Well, I'm John Kelly. I'm a full-time artist, musician, and I've been sort of gigging since I was about 8, actually. I'm a bit of a jack of all trades. I sort of play a little bit of everything, really. So, I started off on piano. That's where I learned to sort of play. And then I jumped to trumpet because it had 3 valves. Usually a chord is at least sort of 3 notes. So you need at least 3 fingers. So that can be problematic for me, unless, I've got a keyboard at a really funny angle. I can do it to a certain extent, but struggle to hold chords down. And this device enables me to really play a full chord just with one finger on the root note and then on the next power, which is the major. Because I haven't got a big stretch, I haven't got a very deep stretch, so everything being very close to me is quite important as a disabled person. Well, I'm John Kelly. I'm a full-time artist, musician, and I've been gigging since I was about 8, actually.
My instrument is an adaptation of existing hardware and software components. While I am not able to realize a prototype in the scope of this project, the next few slides will show you information about the main components. The interoperability of these components is the main challenge to fully realize this instrument. First is the MIDI controller made for tablets, such as the iPad. Note the hexagonal layout of an isomorphic keyboard. Each interval shape is the same no matter where the hands are placed. The stretch and direction for an ascending major third, for one example, is always the same in an isomorphic layout. Next is introducing a MIDI breath controller to not only make the computer-driven audio more expressive, but to tap into the LIS patient's ability to breathe. In the third category of LIS, this instrument would not work for them, as total LIS patients are unable to breathe on their own.
Let me start by giving you a quick demonstration of the sound of sample modeling brass instruments, with the expression being performed on my Tech Control MIDI breath controller. Let's play sample modeling brass right now.
The next component is adding existing hardware to track eye movements. This device uses a near-infrared light beam to track eye movements. It can be figured easily to a variety of individual client needs. Lastly, the humble yet powerful Arduino circuit board computer will meet our interoperability challenges. Its low cost and open source software programs make it an excellent candidate. Many existing tutorials exist to design MIDI controllers out of Arduino boards. This diagram will serve to give you an overview of how the finished instrument will operate. The client provides eye movement and breath outputs to the two controllers. The eye gaze reader will connect directly to the tablet. The client simply looks at the note they want to play. Their breath controls the pitch duration and other modifiers like vibrato. The iPad and breath controller separately send information to the Arduino Uno unit. The Arduino then sends combined MIDI out information to a digital audio workstation running any music production software like Logic, Cubase, Ableton, or others. Through headphones or a speaker, the client hears their musical product. In the literature, music therapy interventions with the LIS client tend to be receptive interventions. This instrument would allow personal expression of the LIS client and enable improvisational and recreative exercises. Many potential other clients could be served. In IAMT, Kogutek et al. Use MIDI information to monitor client progress on goals. How often did the client make notes? What kind of notes and phrases did they play? All of these musical parameters can be recorded through MIDI for later analysis. In pediatric palliative care, this instrument may pique a young client's interest where other types of interventions are disfavored by the client. Again, using MIDI messages as a metric would enable oral, motor, and respiratory exercise to be performed with this instrument and with clients working on oral, motor, and respiratory exercise interventions. Thanks for your attention to this project. I look forward to your questions.
Let me start by giving you a quick demonstration of the sound of sample modeling brass instruments, with the expression being performed on my Tech Control MIDI breath controller. Let's play sample modeling brass right now.
A jack of all trades. I sort of play a little bit of everything really. So, I started off with piano. That's what I learned to sort of play, and then I jumped to trumpet because it had 3 valves. It usually a chord is at least sort of 3 notes, so you need at least 3 fingers. So that can be problematic for me unless I've got a keyboard at a really funny angle. I can do it to a certain extent, but yeah, I struggle to hold chords down. This device enables me to really play a full chord just with 1 finger on the root note and then on the next power, which is the major, because I haven't got a big stretch, I haven't got a very deep